So for combinations, there are a finite number of ways in which n elements can be combined into distinctively different groups of R items. For example, suppose a farmer has a chicken, a rooster, and a duck, and a cage that holds only 2 birds. The possible combinations of 3 birds taken at a time are chicken rooster, chicken duck, and rooster duck. The birds in the cage will not remain stationary, so the combination rooster chicken is not different from chicken rooster. That means that combinations are not order concise. So shown here is the equation that we use for combinations. The number of combinations of n items taken r at a time is how we pronounce the C in parentheses n comma r, and it is pronounced just n chosen r. It is sometimes referred to as the binomial coefficient. So let's get into permutations of different objects types. So suppose n1 objects of one type, such as color, size, shape, etc., are combined with another n sub 2 objects from another type, and so on, such as n3, until you get to a value up to k types. The collection of n, which is equal to n1 plus n2, etc., all the way up to nk, objects forms a population from which arrangements of n items can be formed. The number of permutations of n objects taken n at a time from collection of type k can be shown in this equation. So let's get right into another example problem, because I think example problems are the best way to visualize and have an understanding on how these equations are utilized in the real world. So an urn contains 13 marbles. From those 13, 4 black marbles, 2 red marbles, and 7 yellow marbles. Arrangements of 13 marbles are made. Most nearly, how many unique ways can the 13 marbles be arranged? So from these options, I know I already have the solution being shown, but let's still walk through it. So we know that the marble colors represent different types of objects. The number of permutations of the marbles taken 13 times. So it will be written as the n with no subscript being 13, and each individual object would be their values of 4 being the black marbles, 2 being the red marbles, and 7 being the yellow marbles. So when we plug these values in with the factorial rule in mind, we would end up getting a value of roughly just under 26,000 possible orders for these arrangement of marbles. So that concludes my brief introduction to combinations and permutations under the probability and statistics category. I hope you guys really took something away from watching this video and you guys enjoyed it and found it very helpful. If you did, please feel free to like, comment, and subscribe to my channel. It would really help me out, and I would hope to see you guys in another future video, and have a great day. See you guys.